Okay. And it just got really cold in my house. So cold. Okay, I got this. I got this. I got this. Doesn't look like too many problems, but your teacher's having us do all the problems, and it's usually odd, so it's a little bit of a disappointment. But I'm a kind of big believer with your teacher that there should be like a certain daily amount of practice. It's a really good, like, I do my math homework right when I get home, or I do it right after dinner. Like, there's that constant, like little space of 20 to 30 minutes. This should take less than 20 minutes, I'm hoping. All right, number 12. All right, so they give us the point, 5, 12. And we have an angle in the standard position. And the terminal side goes through the point. So we have 5, 12. If I had to guess, 5, 12 is right here. We have an angle in standard position. So like this, and like this. And then if you notice, you can make a right triangle out of this. I guess I'll use a third color. And here's my right triangle by dropping an altitude. This looks terrible. This point's 5, 12. So the x value is 5 and the y value is 12. We need to find the hypotenuse before we find all our trigonometric values. So we get 5 squared plus 12 squared equals c squared. And we get 25 plus 144 is equal to c squared. 25 plus 144 is 169 is equal to c squared. And everyone should know that that's 13. One of our famous Pythagorean triplets, 5, 12, 13, right triangle. This is 13. And then once I have my right triangle, and this is my angle theta, I can find all the trigonometric values, like sine. Sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tangent theta is opposite over adjacent. Cosecant theta is the reciprocal of sine. Secant theta is the reciprocal of tangent. Reciprocal of cosine. And cotangent is the reciprocal of tangent. And there we go. On to the next problem. These are all done the same. That took 2 minutes. And this is going to be tight, but trying to get this into under 20 minutes. So again, we're going to have our terminal side go to the point -6, 8. We'll just say -6, 8 is right there. And so our terminal side is going to go through that. I'm going to build a right triangle. Here's my right triangle. And this, they'll like, and this is like the confusing part where like SOHCAHTOA doesn't really work, and I prefer the unit circle, but this angle here is our angle theta. We're going to use this reference angle to find all its values, which is nice. So this right here is the reference angle. And I know the base of this triangle is -6. And the height of this triangle is 8, which like just sounds weird, but you got to like roll with it for now until we get to the unit circle, and then everything makes sense. All right. So I'm going to continue here. Little Pythagorean theorem. I get 36 plus 64. I know that's equal to 100. So I get c squared is equal to 100. C is equal to 10. This is just a 3, 4, 5 right triangle that's been doubled. Another Pythagorean triplet. And then I find all my trig values. Sine theta is equal to 8 over 10. Cosine theta is equal to -6 over 10. Tangent theta is equal to 8 over 6. I don't know why I'm not reducing any of these. 8 over -6. Very important. It's in the second quadrant. Tangent will be negative in the second quadrant. Sine will be positive. Cosine will be negative. All right. Cosecant theta, 10 over 8. Secant theta, -10 over 6. And then finally cotangent theta, which is -6 over 8. On to the next. 14. Hoping to get under 20 minutes. Let's see, 3, 0. This one's going to be weird. And again, like in terms of SOHCAHTOA, it's not going to make sense because we can't make a triangle. So like my angle is going to look like, 3, 0 here. So what does that mean? That means I'm an angle of 0 degrees. So I have like, if I were to make a triangle, and I knew this was 0 degrees, then I wouldn't have a height here. My height would be 0. My, I guess in this specific case, this would be 3 and this would be 3 as well, which is like super confusing. Don't like it, but I'm going with it. All right, and then I'm going to find my 6 trigonometric functions. So sine theta is going to be opposite over hypotenuse, which is just 0. Cosine theta is going to be adjacent over hypotenuse, which is just 1. Tangent theta is going to be opposite over adjacent, which is 0. Cosecant theta does not exist. You can't find that value. Secant theta, that's just 1. Cotangent theta, that value does not exist. Can't find it. All right, 15, moving along. Dude, if I can finish the first section in 10 minutes, or around 10 minutes, I'm set. Again, here's 0, -7. 0, -7, which is this point, 0, -7. Okay, I had to like wrap my head around this. Like, what would this triangle look like? Because I mean, technically it's not a triangle, but imagine a triangle, like this. You have a triangle like this, where this length is 7, or -7, basically. And then this length here is 0. So it like comes back to the x-axis. Which, it's not fun. It's like, it's not fun. And so like for the a squared, b squared, c squared to work, this has to be 7. The hypotenuse has to be 7. Those are really confusing, but a couple more days and everything's going to make sense. I hope. If not, that's okay. So sine is going to be opposite over hypotenuse. So we're going to say -1. Cosine theta is going to be adjacent over hypotenuse, which is 0. Tangent theta is equal to -7 over 0, which does not exist. Can't do it. Wait. -7 over 0. Yep. Can't find it. Cosecant theta is equal to -1. Secant theta is equal to does not exist. Cotangent theta equals to, okay, so this, I think this was against this. So it's like adjacent over hypotenuse, adjacent over opposite. So I believe that's going to be 0. Not fun, but whatever. On to the next 16. Hopefully this seems like a normal one. It's normal, but it's not like a Pythagorean triplet. So we have the point 4, -2. That's going to be in the 4th quadrant. So 4, -2 is going to be down there. And so I'm going to build a triangle using this reference angle. And this side is 4, and this side is -2. Make sure you have that negative there. And so we'll say sine of theta is equal to, now you have to find the hypotenuse for whatever reason I forgot. 16 plus 4 is equal to c squared. So I get 20 is equal to c squared. I take the square root, so I should get 2 rad 5 equals c. So this is 2 rad 5. Boom. And then I just plug everything in. So sine is opposite over hypotenuse. So -2 over 2 rad 5. I guess I can rationalize the 2's are going to cancel out. So you get negative rad 5 over 5 cosine theta. Cosine theta is going to be adjacent over hypotenuse. So this is going to be 2 rad 5 over 5, and it's going to be positive. Tangent theta, excuse me, is opposite over adjacent, so negative 2 over 4, or 1/2. And then we'll do the reciprocals. So we're going to flip everything. So cosecant theta is going to be negative rad 5. Secant theta, reciprocal of cosine, which would be rad 5 over 2. And then finally cotangent theta looks like negative 2. All right, whatever, no big deal. 17. I still think we're doing good time. I still think we'll get under that 20 minutes because the next ones aren't bad. Like there's not like find 6 of each one. Here we go. We got negative 9, negative 3. I'll say it's right there. So when I build my triangle, here's my reference angle. Here's negative 9. Here's negative 3. I have to find my hypotenuse. So I got 81 plus 9, which is 89. Oh, 90. Square root of 90 is like 3 square root of 10, I believe. So there's my hypotenuse. Whatever's. Sine of theta is equal to negative 3 over 3 rad 10, which just turns into negative rad 10. Cosine of theta is negative 9 over 3 rad 10, which turns into 3 over rad 10, but I'm going to rationalize, and I get negative 3 rad 10 over 10. I think this should have been over 10, right? Yeah. Tangent theta, opposite over adjacent. So that's going to be 3/9. Or if I want 1/3. Cosecant theta, that'll just be negative rad 10. Secant theta, I'll flip that cosine. That's going to be negative rad 10 over 3. And then finally, tangent theta looks like just 3. Perfect. I hope that makes sense, that tangent's positive in that quadrant. If not, really soon, I promise. 195 degrees. We want to sketch the angle and find its reference angle. Okay, so I'm for sure going to finish under 20 minutes. All right, 195 degrees is going to be like, if this is my angle in standard position, 195 degrees is going to be out here. Yeah, this is my 195. And my reference angle is going to be the positive angle between the terminal side and the x-axis. I know this is 180 degrees, so the reference angle is 15 degrees. Good. Excellent. Excellent. These will go fast, I'm hoping. 19. 285. So we have 285 degrees. I'm going to draw it. Here's my angle or initial side, standard. Go to 285. 285 is going to be over here. This is 270, and this is 360. And just remember, our reference angle is the angle between the terminal side and the x-axis. So is that 55 degrees? Let's do some math here. 285, subtracting. Gonna borrow. I guess I'm gonna borrow. It's gonna turn to 5. So here's 5. I have to borrow again. That's 15. I guess it's 75 degrees. Does that make sense? Yeah, that makes sense. That makes sense. This is 75 degrees is my reference angle, the thing we're looking for. On to 20. 20 is negative 100, negative 250. So here's my reference angle. Here's my angle in standard position. I'm going negative 250, which should be just short here. Boom, boom, boom. Reference angle is in between the x-axis and the terminal side. If this is 180, I guess if I was going like negative 180, this is negative 250. What is that? What is that in between? I'm guessing 70. Yeah, 70 sounds right. The reference angle is 70 degrees, and that's always positive. Dude, my nose is bothering me. Gotta sneeze. I'm not gonna sneeze. On to 21. 7 pi over 4. So again, I'm gonna draw this because I'm comfortable with radians. 7 pi over 4. I believe that's going to end up in the 4th quadrant. I actually really like radians because of reference angles. A lot. So this is like 7 pi over 4. I know this is 2 pi, or if I want, this is the same thing as 8 pi over 4. So how many pi's over 4 are we from 2 pi if we're at 7 pi over 4? That is just a pi over 4 as our reference angle. I know that looks terrible, but that's what it is. 22, negative pi over 4. So again, here's negative pi over 4. But I want the reference angle, which is pretty easy because, you know, this is just going to be pi over 4. Positive. No big deal. Dude, I'm on to the last one. We're way under 20 minutes. Not way under, but a decent amount. I got 400 degrees. I'm going to draw 400 degrees. Now, 400 degrees, if this is my standard position, kind of goes all the way around like that. I'm going to draw it. That's 400 degrees. And its reference angle is from 360 degrees. And that would simply be 40 degrees. Boom, done. 18 minutes, not bad. As planned. Under 20 minutes. Again, daily practice. I'm like old school about that. Like, it should be done. Thank you, guys.